Right. Yeah. So greenhouse structures and environmental controls. So first, I like to go kind of over what is a greenhouse. There's a lot of jargon. You've probably heard hot house, glass house, cold frames. Cold frames are what the nursery guys call basically a high tunnel. They're normally a lot shorter. That's what they use to overwinter plants. Protected agriculture, high tunnels. It's just basically a stripped down greenhouse with natural ventilation, no heat. Um, Hoop houses, same as a high tunnel cold frame. And then controlled environmental agriculture, and that's the CEA. That's the word that's been the trendy word or phrase that's been going around for a little while now. I'm not a fan of it because I don't feel like we're ever really controlling the environment in the greenhouse, at least not in the Southeast. We're modifying it the best we can, but we are definitely not in control, and that's primarily because of the heat. And what's the purpose of the greenhouse? Obviously, we want to modify the environment, and then we can, protect the crops, whether it's from insects, environmental extremes, or even biosecurity. And there's all different kinds of shapes and styles of greenhouses. We're probably only going to be seeing a couple of different styles here in the Southeast. You might have a greenhouse that's what we call freestanding. It's standing alone. And I'd say the average size of a structure is about 30 by 96. I don't know what's magical about that, but that's just the way it's been forever. That's about 2,800 square feet, 100 by 96. So that would be called a freestanding greenhouse. It's just one structure. And then you might have gutter connected or multi-bay units, and they're all connected by a gutter. And the reason for the gutter is that water running off the roof has to go somewhere. Otherwise, it'll pile up on those poly sheeting and cause a lot of problems. And there's different coverings for different style greenhouses. Glass is what's a lot of people think of, especially folks that aren't dealing with commercial greenhouses. And glass is still widely used, especially in northern latitudes, excuse me, where they may have lower light levels in the wintertime, and they're trying to get as much light as they can. It's got excellent light penetration, probably the best. And so a lot of the northern greenhouses are still glass. You don't see a lot of that in the Southeast. It's rigid. It is very expensive. It's a lot of maintenance involved with it. It doesn't hold heat very well. Every time there's a joint in the glass, a pane of glass, there's a potential for heat loss there. And it's really only adapted for straight sides, although you might see some kind of cool features in some of the old Victorian style greenhouses, in England at the Kew or places like that. Polycarbonate panels, they could be twin wall or single wall. They're rigid. They're also expensive, but they have excellent heat retention, okay light penetration. These also don't work very well on curves. So you're primarily going to see these on straight sides. Some folks will use this exclusively on their end walls and maybe on their side walls. A lot of garden centers like to use this as well. It's nice, this polycarbonate sheeting, because it lasts a long time and a lot of people don't want to have to recover their greenhouse. But it's good for gabled roof, where it looks like a house, an A-frame, or the sidewalls. And then what most of the greenhouses we're going to see in the South are going to have poly sheeting. That's typically going to have a Quonset style top to it, a semicircle hoop to it that can accommodate, that poly sheeting. It is the cheapest. It is extremely inexpensive. You're less than maybe $1,500 to cover a greenhouse. You're going to have to replace it between 1 and 4 years, depending on the gradation of poly you get, the thickness. They have 1 year poly and they have poly that can last several years. A lot of the nurseries, they'll pull their plastic off in the summertime, and so they'll be using the 1 year plastic. Now, most folks will do what's called double wall, where they'll have two pieces of plastic. They'll use what they call a squirrel cage fan. That's just a little blower. It runs 24/7, and it inflates those two layers and makes a little bit of a bubble. It might be, 4 to 6 inches in width, that bubble, and that volume of air acts like insulation. Okay, so it reduces your heat loss from your surface area by 20 to 30%. Most of our heat loss in a greenhouse is through the surface area. And so how is glazing attached? A lot of people are curious about this. Polylock, it's aluminum. It's like an aluminum channel system where there's another piece of aluminum that snaps in. Wiggle wire, that's what I prefer to use. It's a wire that you wiggle in and out of the same type of aluminum track. I don't know if you can see it. See my mouse is right here. Wood slats and screws. A lot of the older nurseries will still use this. And strapping and staples. You can see this black strapping on the end wall of this house. This is really inexpensive. It's typically used for the 1-year plastic, and they'll just put this black nylon strapping over any sort of wood where they're wanting to attach it, and then they'll hammer staples through that. If you were to hammer staples just through the plastic, it'll tear. So this nylon strapping kind of helps that. And some people will cut PVC pipe in slits and use it as sort of a snapping type system. So there's gable roofs, like the sort of A-frame, and that's still used a little bit. It's typically going to be for the rigid stuff, although I've seen some people pull off using poly sheets on it. A lot of the DIY greenhouses, it's just easier to build this gable type roof than to try to bend hoops. And I know some floriculture operations that have done this and it works pretty well for them. The Quonset style roof, that's what I was saying earlier, is predominant here in the Southeast. It's easy to construct. It's typically pretty inexpensive. Works good with films. You might see a lot of the older nurseries have like a ground to ground Quonset where the hoop extends from one side all the way to the other. But most greenhouses for vegetable culture, they want a higher sidewall. So they'll have straight sidewalls with just a Quonset top on the top, roof on the top. We're interested in sunlight, so we're trying to maximize that. And at our latitude, we're going to be orienting our greenhouses, if they're single bay, freestanding, north to south. And a lot of people will even do the same orientation with gutter connected. But the idea is you want the sun to pass over the top of the house. If you were to run it east to west, the sun is going to favor that south side, especially in the winter. And you're always going to have a shadow on that north side. So by orienting it east to west, you're maximize the sunlight while it's passing over the width of the greenhouse versus the length of the greenhouse. Like I said earlier, if you orient it east to west, you're going to have that shadow. I've seen it for floriculture crops or some stuff that's not as sensitive and not needing as much sunlight. It's not a big deal, but for our greenhouse vegetables and hydroponics, we want that light. And so that shadow can make a big difference. It's also important if you were to orient it east and west and you had tall crops like a tomato. So we've already gone over how we grow tomatoes and cucumbers on a trellis. And so those are grown vertically. And so if you have your greenhouse oriented east and west, that sun, as it's moving across that southern sky, that declination is such that you're going to have one crop shadowing another crop, and so that can cut down on your production. Another reason why you want to orient it north to south with these taller crops. And so how does a greenhouse work? Well, it's amazing to me how it works. It's, nuclear fusion from the sun. And in just a short amount of time, those photons are shooting at the earth, going through our atmosphere. That is short wavelengths of solar radiation. And they're going to go through our greenhouse glazing or our covering of our greenhouse, whether it's plastic or glass. It's going to hit stuff. Then it's re-radiated, but this time it's radiated, it turns into long wavelengths. And so those long wavelengths cannot leave that film or that covering as fast as it can be gained. So you get heat gain. Same effect in your car. That's the same thing. So when you open your car and it's hot as fire in there, same effect. Same reason why the earth is warm. It's called the greenhouse effect. Same thing with our atmosphere. But this results in a heat gain because heat is gained faster than it can be lost. And it's incredible how much heat a greenhouse can gain. What's sad is how poor it can hold it at night. It can pick it up really well during the day, but it doesn't hold it well at night. And so it can get very, very hot on a sunny day, regardless of the time of year. It can pick up about 1 million BTUs of heat energy every single hour. And that's the equivalent of about 10 gallons of propane getting burnt an hour, or burning 3 car tires. There's a lot of BTUs in a car tire. Burning 3 car tires every hour. Or my favorite is, it's like having 50 kitchen ovens on all at the same time in that greenhouse running full blast. It's a lot of BTUs, and you got to do something with that heat. Everybody thinks plants like it hot, but they don't like it hot when it gets over 120 degrees. In fact, they don't really like being over 85 degrees for most plants. So if you get too warm, the plant's metabolism slows down or even can stop. You know, a lot of times crops in the middle of the summer, they'll really suffer from those high heats. If you're trying to grow tomatoes during the summer, it's almost impossible here, but they become less productive, you know, again, under 85. Lycopene can become a problem. The production of lycopene, where what makes the tomato turn red. You'll get tip burn in lettuce, and every crop has its optimum operating temperature, and so we're really trying to hit that optimum temperature. Like I said earlier, if you go over 85, lycopene can be inhibited. If you go below 60 with tomatoes, 64 depending on the cultivar, you're gonna get some flowers aborted. All right, and like I said earlier, lettuce, you get too hot, you get bolting, tip burn, bitterness. And the worst problem for us is Pythium. You know, our plants get stressed and Pythium moves in and can wipe out a crop. You can see this crop on the right. It's sitting in water. It's a hydroponic solution it is growing in, but it is wilting. And that's because every bit of the roots have rotted off. And so how do you reduce these greenhouse temperatures? Okay, there's a couple different options. You can do that mainly through ventilation. It can be natural or passive ventilation through wind or mechanical using fans. You can use shade or evaporative cooling. We're going to kind of go over all those. One important thing, to me, this is the most important thing that we have the least amount of information on, is how the greenhouse height can impact temperature management. All right, we don't know the optimum greenhouse height for the Southeast. You know, I can tell you just from my experience, anecdotally, the taller the better, you know, and I'll talk a little bit about that in a minute. But this is how I learned this the hard way. This is one of the first greenhouses I ever built. This little Les production, it was a project over in West Alabama. And I got this old frame from a nursery that went out of business. It was probably from the 70s. And back, you know, pre-90s, a lot of the greenhouses were really short. The idea was to keep the heat low to the crop. And so I had this ground-to-ground Quonset. It was probably 10 foot at the apex and maybe a 4-foot sidewall on it. And I had two little 36-inch fans in there. And man, it did not work. So I added more fans. Still did not work. And I've learned through a lot of pain is the shorter the greenhouse, the hotter it's going to get, especially if you have clients who are interested in getting hobby houses. A lot of those are maybe 6-foot sidewall and just 8 foot at the apex, and they can turn into little ovens. They're okay in the winter. You're still going to have to ventilate, but they're really hard to manage temperature in those short greenhouses just because of there's such a low volume of air in there. So an example I like to give on how this works is if I had 2 pots of water on the stove, one was smaller than the other or half full, which one's going to boil first? The one that's going to boil first is the one with the least amount of water in it. Okay, because there's a lower volume, there's less to have to heat up. All right, and the larger there is, it's got more heat capacity. It can kind of buffer those temperatures better. So a smaller pot of water is kind of like a smaller greenhouse. I have a smaller volume of air, but I have a lot of surface area of heat gain. You know, so you can look at this example on the right. I've got a tall 15-foot greenhouse, calling that greenhouse A, and then B has got a 5-foot sidewall. All right. So greenhouse A is just shy of 60,000 cubic feet in volume, whereas greenhouse B is 37,000. Okay. So if you think about it, if you're looking at surface area of those greenhouses, so that's where I'm getting my heat is from that surface area of the cladding, right? Of the film. And you look at the volume, you know, it's a pretty big difference. So greenhouse A has got 60% more air volume than greenhouse B. So it takes longer to heat up that air or for that air to lose heat. Okay. Now greenhouse B has 25% more surface area exposed to solar radiation than greenhouse A. Okay. So 10 feet can make a big impact on heat gain. You know, so what's the optimum size? I wish I knew. We're working on that as part of the GRACE project. And we're still trying to determine that, but I can tell you that up to a point, taller is better. It's more expensive, but it is better to have a taller house. And a lot of people worry about, okay, well, that's a lot of air to heat, right? Well, it is, but you can look at this houses right here. This is some of the most advanced greenhouses in the world. In the Netherlands, they have high-tech greenhouses. They use this in northern latitudes. And I'll show you, I don't know if you can see my pointer, but that's about head height right there. That's how tall that greenhouse is. They're massive, massive. And so it gets cold in the Netherlands, and yet they're still using very tall greenhouses. And you've got a large volume of warm air, so it takes longer for you to lose that heat because it's all mostly based on surface area. That's where we get most of our heat loss. Okay. So I got a large volume of air. It takes longer to heat up and also takes longer for it to cool down. So let's get back to ventilation, natural ventilation. Wind, it takes about a 2 to 3 mile per hour minimum to evacuate the heat out of an average size greenhouse with open sides. And you want about 1 air exchange per minute. And that's true for whether you're using fans or if you're using natural ventilation or passive ventilation. That air exchange is not based on the entire volume of the greenhouse. It's based on about 8 to 10 feet of vertical height and then your surface area. So you're looking to get 1 air exchange per minute to keep that greenhouse from getting too hot. Natural ventilation, you don't see a lot of this in the Southeast. We probably should be using it more. You'll see this a lot in tropical type greenhouses or screen houses. They'll have roof vents. Hot air rises because it's less dense. Also, that water vapor is less dense. And so hot air escapes through the roof, through a vent. Sometimes they'll have these at different configurations in terms of how open it is or whether it's on the windy side of the greenhouse or not to help pull that air out. And you have side vents where cool air can come in. And this is the way some greenhouses are ventilated. There's also a kind of a pushing effect or a vacuum effect, depending on the direction the wind's blowing. So as it passes over the vent, it can kind of pull that hot air out or push it as well. The vent to floor ratio. So this is from the American Society of Agriculture Engineers. This is an old number and it probably needs to be reinvestigated because I think it needs to be much higher, at least for us in the South. 15 to 25% of your ventilation area, whatever your floor area is, it needs to be about 15 to 25% of that needs to be ventilation area. I just think just max it out. The most ventilation you can get, the better. That also speaks to how a taller greenhouse would work better because you've got more surface area for ventilation. And the taller you are, the more wind shear you're going to get. So the higher you are, the more wind is actually going to be able to get through that greenhouse. Now you can think about this. A lot of the high tunnels, they might have a 4-foot sidewall on them for ventilation where they can be removed in the spring or fall, all through the summer if you can grow in it. How much wind do you actually get going through a greenhouse at 4 feet? You ever feel wind around 4 feet above the ground? There's not much, right? So that's why a lot of these high tunnel designs, they're not real adequate for the Southeast, just because I feel like they're designed more for northern climates where you're exchanging cooler air. Here we need as much ventilation area as possible. And that means high sidewalls. Again, you want 1 air exchange per minute. So mechanical ventilation, exhaust fans, we're going to be exhausting the air. We're not pushing air into the greenhouse. We're pulling it out with fans. It's going to be either a 36 to 56 inch blades on these fans. A lot of the greenhouse guys, they're using some engineering numbers that I think probably need to be revisited. I think the more fan ventilation you can get, the better. Now, you don't want to go over about a 3 mile per hour wind with your fans, or at least you don't want to go over 1 air exchange per hour based on some past research, because it could dry out your plants. But I think they can handle it, especially in a hydroponic situation. I would try to maximize my exhaust rate to a point. You don't want a hurricane force winds in there. You don't want too big of a power bill. So you're typically going to have 1.5 to 2 horsepower motors running, single or 3-phase. If you use 3-phase, it may save on your power bill a little bit. Fans, if you're going to have fan vented greenhouse, you want to have spare parts, extra motors, extra fan belts, and know how to install those. You also going to want to have a generator on site dedicated to that greenhouse on a transfer switch. So if you're in the summer, power goes out, these fans have to run. It takes less than an hour and it can be 120 degrees in there. Some rules of thumb for fans: fans should not be spaced more than 25 feet apart. You want to avoid your houses being over 150 feet. Okay, they're just not as efficient if they're having to pull more than 150 feet. You want to have your fans exhaust in the same direction as the prevailing wind. If you don't, if that's not an option, then you need to up your fan size a little bit. And the vents should be about 1.25 to 1.5 times the combined area of the exhaust fan. So whatever that surface area is of that exhaust fan, you need to multiply that times 1.25 or 1.5. Even bigger is fine with the ventilation to make sure you're going to get enough pull. Otherwise, you'll get a vacuum effect in that greenhouse. If you don't have enough vent area on the opposite side of the greenhouse where you're pulling air from, you'll notice that door wants to slam on you when you open it up. And you'll see the plastic kind of pull in, and that's hard on your fans. It builds up the amps and it can burn up your motor over time. And you're spending energy that's not going to good ventilation then. You want about 25 feet of clearance outside the greenhouse so that exhausted air can get out of the way. Those are just some rules of thumb for using fans. You may have louvers. These can be mechanized with a little motor. That's probably the best method. They can also, if your fans are big enough, the fan, just the draft itself pulling through that, can open up these louvers as well. You would want to flip them, reverse them, than what you're seeing here. And just the draw of that air can open them up. But if you're going to use louvers, a motor is preferred. You can also have wall vents. This is more and more common where you have this little motor spins this pipe. It can pull open that vent to accommodate as much ventilation as you possibly can get. Now, if you're going to get an exclusion system that excludes insects, that's great, but you're going to need to make the surface area of that screening as large as you can. And there's engineers can help you with this. The reason for that is if I were to just put screening on my vents and not increase the surface area, my fans are going to have a hard time drawing air through it. And just like I said earlier, not having a large enough vent area, it's going to strain those fans. The amps are going to go up. It can burn up my fans. And I'm not pulling enough air through the greenhouse. So I'm burning electricity that's not helping me out. So you want to either put an extra bow on the back of the greenhouse and you can cover that end with insect screening, or you can build a box like you see here. It definitely helps with insects, but you got to accommodate your fans if you're going to do that. And it's best to talk to an expert before committing to it. Roll up sides and fans. Occasionally I'll pull up to a greenhouse operation, typically nonprofits and stuff, and they'll have their sides up and their fans running. And that's a poor use of electricity because the fans are only going to draw where there's the least resistance, which means about 4 or 5 feet down the sidewall, right next to the fans. It's not going to be drawing air through the whole greenhouse. So having that combination of roll up sides and fans is great. In the middle of summer, it might be that you just want to roll the sides up and turn the fans off because you're going to need ventilation 24/7 pretty much. In the wintertime, it can help you out to have those fans and automate because they're going to be coming on and off more often. So there's nothing wrong with having both, but you don't want to have them both running at the same time. You don't want your sidewalls up and your fans running at the same time. There's a lot of different options that have hand crank roll up sides. They have options where you can put a little battery powered drill on this and zip it up real quick. But this rolls up the side here. It can be automated. Here's one I bought off Amazon. I've been trying out. I'm trying to rig it up where it's solar powered. But it's got a thermostat on it. It can raise and lower your sidewall. A lot of potential here for high tunnels. I don't know how long it's going to last, but if you were to buy this commercial grade, you're looking for the whole kit and it works great. It's probably going to be $3,000 to $5,000. So this is just the motor. Like I said, it's a cheap one off Amazon. It's working okay. I don't know how long it's going to last compared to a commercial grade system. So even if you have a fan vented greenhouse and it's blowing and it's designed correctly, you're still going to get about a 7 to 8 degree temperature rise from one end of the greenhouse to the other. As it's going through that 96 feet or greater, it's just picking up heat energy. So that air temperature is going to be about an 8 degree difference from the inlet to the exit of that greenhouse. So one thing you can do is cool that air as it comes in with an evaporative cooling system. So you might have seen these in chicken houses. They use them in greenhouses as well. So it uses the latent uh, heat energy. So as water vapor, let me back up just a little bit. You see this cellulosic material almost looks like cardboard. It kind of is. The idea behind this is create a lot of surface area. Okay. So at the top of this, water drips down and saturates this as it's running. All right. The, this is put over the greenhouse vent. All right. So when the fans kick on, it pulls air through that. So as that air comes through, it comes in contact with that moisture. All right. And so that moisture, because it's spread so thin, so much surface area, it can evaporate. And when it does, that heat energy is transferred from the air into the water vapor. And it can cool your greenhouse, cool the air down. It works really well in areas of low humidity. Okay. So we have high humidity in the south, but a lot of successful lettuce operations I've seen have cooling pad systems, at least in Alabama and north. I can't speak for Florida. It may be too hot for these to work well there, but they still work in my opinion if they're sized correctly, and it can cool that air as it comes in. It works really good out west. It's almost like air conditioning if you stand next to it. Another option is to block some of that solar radiation coming in the greenhouse by using shade cloth. Now you can use cloth if you have rigid greenhouses that won't accommodate cloth. They have paint you can spray on your greenhouse. It's called whitewashing. It's messy. I don't like it. Most people are using some sort of shade cloth. Shade can be applied over the greenhouse. In most cases, it is. Some more expensive high-tech greenhouses will have shade inside the greenhouse that's retractable. I think it works better outside of the greenhouse. Um, that's just been my experience, but it's a lot of maintenance to put it on and off. There's a lot of different types of shade cloth out there. You can get knit or woven. Woven is what a lot of the nursery guys use. Knit, it will fray on you. Okay. Now the knit doesn't fray as bad, but I don't really know. I don't see it used as often, but it should be. It's a good product. They come in different percentages, 30, 50, 60, 80, you name it, all different kinds of shade percentages. Just because it's saying it's 50% shade does not mean it's going to reduce your temperature by 50%. It's just reducing that solar radiation by 50%. For growing vegetables in the summer, I would have around 50% shade for vegetable production. I wouldn't go much else. I know it says greater than 50, but I wouldn't go much over 50% for vegetable production. Lettuce can handle that fine. You're going to see a drop in production with tomatoes, and cucumbers are okay with it a little bit. But you go over 50%, it's a little too dark for those summer months. At least in Alabama, we're putting our shade on in late April, early May, and then we're going to be taking it off around October. And the further north you go, that's going to change. So heating, we're not going to spend a lot of time on heating, but in most cases for heating, you're going to use a forced air gas heater, and that could be either liquid propane LP or natural gas. Natural gas is cheaper, so if your client is interested in setting up a greenhouse operation, before they buy any property, if there's natural gas in the area, try to find land that has access to that natural gas because it's cheaper than the propane. You also don't have to deal with having it ordered in. It's just on supply all the time. If you're in an area where there's a lot of poultry production, a lot of times you can get a good commercial rate for LP. Otherwise, you definitely don't want to, you want to check with your gas company and make sure you're not going to be paying a residential rate for LP because it will break the bank. But you're going to be using a forced air gas heater. They're great. They last for years. They're very dependable. They don't require a lot of maintenance. And I typically like to have two in a greenhouse. Most manufacturers, it, they're only going to suggest one, but if it were me, I would have at least two. You could split the BTU need between the two or just have two with the maximum BTUs needed. But if one goes out and it's the middle of the winter, you don't want to be stuck in that situation. There's alternative and renewable sources. A lot of your clients are going to ask about that because of the expense of heating. It is very expensive to heat a greenhouse through the winter. They have wood pellet heaters, geothermal systems. It's really going to be dependent on the location, whether you get an ROI, return on investment, with this alternative heating sources. Okay. The further north you go, the more of return on investment, the faster you're going to reach that return on investment compared to the southern latitudes. Okay. I wouldn't even pay attention to this if I was in South Alabama or Florida. Okay. You're not going to, you don't have a high enough heat demand for it to pay for itself. Let me give you a little example. A forced air gas heater is going to cost you less than $2,000, maybe $1,200 for a 200,000 BTU unit, where that same BTU output on a wood pellet heater, it could be anywhere from $8,000 to $15,000, depending on how big it is. Geothermal, the same thing. Geothermal, the actual heat pump system is not expensive, but the geothermal system that's going in the ground is expensive. So it takes a long time to pay those off. If you do have clients that are just dead set on this, I don't know the current status of these grants, but USDA Rural Development has had a program, I don't know if they still do, called REAP, where they would cost share a percentage of that alternative energy equipment. Okay, and it was a pretty good chunk of change. You could talk to your rural development office about that. Just given the current situation with funding, federal funding, I would doubt it's still around, but worth checking out nonetheless. Sometimes folks want to put a non-vented gas heater in there, and you're immediately going to think, okay, I'm not venting that exhaust. It's just going to the greenhouse. Yes, it is. Can it give you carbon monoxide poisoning? It could. It's got to run a lot to do that. A lot of chicken houses will have non-vented heaters. For us, though, I recommend using a vented heater. The efficiency is actually going to be about the same. People want to use non-vented because they have a higher efficiency. See, for a vented heater, you can see those kind of ribs in the middle of the heater to the left. That's a heat exchanger. So hot air, or the exhaust, goes through those pipes and a fan blows through them, and that heat gets exchanged from the hot exhaust air through the metal pipes and into the air, and that's what heats up the air. Okay. And they're about 80% efficient. Whereas, this one on the right, it's non-vented. It's just blown exhaust, burnt exhaust into the greenhouse air. All right. And so it's going to have a much higher efficiency, but because you are building up gases in there, not just carbon monoxide, really, sulfur dioxide and ethylene. Ethylene can make your flowers abort. Sulfur dioxide can cause phytotoxicity. That's in the exhaust of these systems. You can actually benefit from some of that carbon monoxide with your crop, but you're going to have to vent that hot air at night to get rid of some of that exhaust. It also puts a lot of moisture in the air. So for those reasons and just safety, most operations are now using vented type heaters. Controllers, my slide here is pretty antiquated because they have much more advanced ones now, but you can see you just have this little thermostat here. I've used these. I can't stand them, especially have different stages in your greenhouse. For example, you might have each fan on a thermostat in your cooling wall, one of these little thermostats, and there might be plus or minus 5 degrees. And so it's really hard to get everything in sync, On the far right, you have a computerized system, which more people are going to these days. And I would recommend, they even have it now where they will connect to the internet and you can operate it on your mobile device, which is great. You can monitor and make adjustments to your environmental controls with your phone. It's incredible. I would spend the extra money. You're probably looking at $50 for that thermostat on the left, and you're looking at probably $3,000 for the thermostat on the right. But if you're in this for business, I would definitely recommend getting the nicer, upgraded computerized type system. So I mentioned greenhouse height earlier, and that's a design criteria. Like I said, I don't have exact numbers on what's the proper height. I can tell you that over 8 feet would be great. Even over 12 feet would be even better, but you're starting to add a lot more cost to your greenhouse because you got a lot of wind shear, you're going to have more metal in that house to support that structure. It gets more expensive. So the taller the house, you got an increase in material cost. Um, even if you're going to have natural ventilation, which South Alabama down into Florida, a lot of greenhouse operations are using natural ventilation in the winter months. It'd be nice to have that automated because it's going to change drastically during the day. But I think the taller the greenhouse, the better. That's just kind of my take home message from here. If you have want to learn more about greenhouse environmental controls or send stuff to your clients, University of Florida has some really great publications. We have one at Auburn. You can reach it with that QR code here. But if you can go to the IFAS website, type in greenhouse or environmental controls, we have a lot of resources there. Really good publications out there. So that's about all I got, and I will be glad to take any questions if we have any.